Hello guys, welcome to another section dealing with proportions, but this time we will be dealing with similar figures. So today you will be learning how to solve problems involving similar figures. Vocabulary for today are similar, corresponding sides, and corresponding angles. Now, similar figures are figures that have the same shape but not necessarily the same size. Now, when you see this symbol, it means similar to. Now, these two shapes here are similar. So here you are going to have corresponding angles. Now, the corresponding angles, they are in the same position. They are relative in position. So C right here corresponds to angle F. Again, they are in the same position. And you can have angle B right here correspond to angle E, and angle A over here will correspond to angle D. Now, same thing goes for their sides. Their sides will be in the corresponding sides will be in relative position. So, for example, AB, segment AB, this side right here, will correspond to DE. Same as BC will correspond to EF. If you see, they are on the same position. And AC will correspond to DF. DF right here. Again, whenever you guys see those lines, it means that they are similar. Now, special things about similar figures. When two figures are similar, they will have the corresponding sides, and the corresponding angles will be equal. And then you have the ratio of the lengths of the corresponding sides will be proportional. That means the two ratios will be equal to one another. Alright, so let's take a look at this one here. Okay, so here we need to compare to see if those two triangles here are similar. So you need to remember, when two shapes are similar, their corresponding angles will be equal to one another, and also their corresponding sides will be proportional. So let's take a look here. First, let's go ahead and take a look at their angle. So we have here angle B will be correspond to angle E. Remember, they need to be in the same position. So this is B, so that means B is correspond to E, and they're both equal to 129. So far so good. And then here we have angle A. Angle A will be correspond to angle F. Angle A will be corresponding to angle D, and angle D is right here. So they're both 33, so that is great. Angle C will correspond to angle F. If you look, they're in the same position. If you were to picture you flipping this triangle to make it look the same, they will be in the exact same position. But not every time they will give it to you in the same position. Sometimes they might rotate them, or sometimes they might flip the picture. So you need to make sure you visualize what is happening. So if we were to flip this, hold it here and flip it, then you will see that A will correspond to D, and B will correspond to E, and C will correspond to F. So far so good. They both, all the corresponding angles are equal to one another. Now, the next thing we need to look at is to look at their corresponding sides. Now, the corresponding sides need to be proportional. So that means that the ratios need to be equal to one another. So let's take a look. Let's take a look at AC. So here we have the segment AC. From A to C needs to correspond to which one? AC will correspond to DF. Okay, so the ratio of A to C will correspond to D to F. Now we have segment AB will correspond to segment DF. So if we look again, AB will correspond to DE. And then this one, BC, will correspond to EF. Now, remember one important thing when we set up proportions that, for example, if you look on top, all on top, I have the smaller one, the smaller triangle, and at the bottom, I have the larger triangle. So I cannot start by putting the smaller triangle on top and then larger one at the bottom, and then when I get in here I put the larger one on top and then the smallest one at the bottom. I cannot. Okay, so now that we have looked, we have set up the corresponding sides. Now we need to go ahead and plug in the numbers. So the length of AC from here to here was 10, and DF is 40. We need to see if that is equal to AB, which is 4, to DE, which was 16, and BC, which was 7, and then EF, which was 28. Alright, now one way is that we can see if these are equal to one another. We can actually reduce them to their lowest terms. So 10 over 4, we know that's going to be 1/4. And then 4, 16, we divide both of them by 4, and we also get 1/4. And then 7 over 28, we'll divide both of them by 7, and we also get 1/4. Alright, so also another way is to find their cross products. Remember, they are proportions. 16, that will also give us 160. Another, and then we do the same for the other ones. But the best way is to reduce them to their lowest term, and then we can see that this is 1 to 4, 1 to 4. And later on, in the next lesson, when we deal with scaling, you will be able to see what these numbers mean. Okay, so go ahead and try. Let's go ahead and test out to see if these two triangles are similar. Pause, come back, and to get the answer. Alright, welcome back. So here we go. So here they do not give us the angles. So the only things that we have to go on are the sides. So first we set up the corresponding sides. So here we have AB, which is right here. Alright, so we have AB will be correspond to DE. And then we have BC will correspond to EF. And which is right here. And then we have AC, which is different color. AC will correspond to DF. And then what we do now is plug in the numbers. So we have 3 to 9, 7 to 21, and 9 to 27. And then the next thing we want to do is to go ahead and reduce them. So 3 9s can be reduced to 1/3, 721 again to 1/3, and 927. To find everything by 9, we get 1 to 3. So these can be reduced all to 1 to 3 ratios. So yes, those two triangles will be similar. Okay, so now that you understand similar figures, let's go ahead and use that knowledge to find indirect measurement. So indirect measurement is a method of using proportions to find an unknown length or distance in similar figures. So for example, if they tell me that those two triangles are similar and I need to find one of the missing length, Knowing that their corresponding sides are proportional, I can set up a proportion to find the missing length. So, for example, here they tell me that those two are similar. Remember, the symbol for similar is the little wiggly line. Okay, so and they give me the length of BC is 6. I know the length of AC is 11.6. And on the other one, I know the length of HJ and the length of G, GJ. And but however, I need to find the missing one right here. So knowing that this is similar to that one, I can go ahead and set up the proportions and then solve for X, the missing length that I do not know. So let me go ahead and use only the sides that I know the values for. Okay, so BC I know will correspond to HG. So BC is here and HG is right here. So BC will correspond to HG. And that will be equal. So now I have a choice. I can use oh yes, they don't give us the length of this one is 10. So now I have a choice of using either AB or AC. So again, it's your choice. So I'm going to choose to use AB because there's no decimals and that will make life a little easier. So AB will correspond to JG on the smaller one. Okay, so now that I found their proportion, the corresponding sides, and now I can go ahead and plug in their numbers. BC was 6 and HG we do not know, so I'll put an X right here. Now AB is 10 and then JG is 5. Okay, so now we can go ahead and find their cross products to solve for the missing value for HG, which is the one we are finding, this one. Okay, so now we can do 6 times 5 will equal to 10 times X, and that will be 30 is equal to 10X, and divide both sides, we see that X is 3. Alright, so this right here, the side right here will be 3 centimeters. Again, knowing that their sides are proportional. Another thing that again you guys need to be very careful of is this. I'm comparing here the big triangle to the small triangle. Okay, I could also do small to big, but then everything will be switched. It will be HG over BC over AB. Again, so as long as everything is consistent, okay, and then we set up the proportions and we will still get the same answer. Okay, so now go ahead and try this one and see if you can find the missing value on right here on the smaller triangle. Remember, the bigger one is similar to the little triangle. So let's find the missing value. All right, go ahead. Don't wait there. Okay, so now I know some information here. I have this side, they do not name them. So I know this side, 8 inch, will correspond to this side on the smaller one, 2 inch. Again, notice again, I'm doing bigger to small. Okay, and then again for the big one, this side, which will be 12 inch, will correspond to this side that I do not know. Let me use different ink color. This one and that one. Again, I cannot go ahead and put my question mark on top because I started with the big one first. So I have to make sure everything is consistent. Again, very important. And then in the small one, We do not know the side. And now again we can find the cross product. So I know 8 times x will equal to 12 times 2. So that will be 8x will equal to 24. And when we divide both sides by 8, and x again here will be 3. 3 inches. So this right here will be 3 inches for this small triangle. Okay, so again, make sure the most important thing where kids usually make mistakes is by flipping things around. We have to be consistent when we set up the proportions. Okay, so here we have a problem. We have city officials want to know the height of a traffic light. Estimate the height of the traffic light. So here they tell you that the stop sign is similar to the shadow of the stop sign is similar to the shadow of the traffic light. So use that information to find out the height of the traffic light. Go ahead, pause, and then come back to get the answer. Alright, welcome back. So here I'm going to set shadow to height, to the actual height. Okay, so here I have the shadow of the stop sign is 27.25. Stop sign, which would be 27.25. And the height of the stop sign, which would be 15 feet. To the shadow of the traffic light, which would be 48.75. And to its height, which I do not know. Shadow to shadow and height to height, that would be no problem as well. If I were to do 27.25 over 48.75, again that would be the shadows, and then the height of the stop sign, which would be 15, to the height that I do not know. Again, if you see here, it's the exact same thing. When we find the cross product, we will still be doing 48.75 times 15 divided by 27.25. So that is how we will set up the proportions. Again, there's different ways that we can solve them. Alright, so let's get out of here and let's see the exact answer. Alright, so since here they want an estimate, so we could basically just round these numbers. So the height will be approximately 30. Okay, when we find the cross product, 50 times 3 divided by 5. Alright, here's another one. Here we are trying to find the height of the pole. Now keep in mind, we will be applying these in class, so we'll be going around the schools to measure the height of different objects using our shadow. So make sure you understand this very well. Okay, go ahead and find this and then come back and get the answer. Alright, welcome back. So here we are trying to find the height of the light pole. So again, here we can set up the person is the height of the person, which is 5, to the shadow of the person, which is 7, and the height of the shadow, which is x, to 42. And we could have also set it up differently. We could do x to 7, so we could also do x to 5, compare the heights. X to 5 is to 42 to 7, or we could have flipped them around. Alright, well, that's it for today. Make sure you guys really understand these concepts. Rewatch the video. I know it's a little longer than normal, but I wanted to make sure that I go really slow. Any questions that you guys have, make sure you post your questions right away on Edmodo so I can help you. Okay, you have a good one. Bye bye, see you in class.